Okay, data center industry experiencing significant change on multiple fronts, I guess, but are there any particular pressures or the biggest pressure you see facing the data center operators today? What do you think is particularly challenging for them?
I think we've got multiple challenges at the moment. I think the first one that I'd touch on is the ever-changing customer requirements. We're in a period of development. Regarding high performance compute for applications like AI and machine learning, and as such, they're driving end user requirements to change and evolve very, very rapidly in this space. The other challenge that we have is the utility power, and related to what I just mentioned. The demands of data centers and the power these days are really very high, and it's becoming increasingly challenging to secure power and secure power that's delivered on time. And also, furthermore, is the escalating construction costs. So, we have, it's no secret we have a labour and skill shortage in the industry, supply chain disruptions, and material inflation. So, it's a challenge to keep on top of that. And we have also, particularly for Colt DCS as a global developer, we have, lots of different regulations coming into the data center space, which impact us in different regions. So trying to stay on top of the different regulations while maintaining a global approach is also quite a big challenge.
Yeah, and there seems to be, partly in response to some or all of those challenges you mentioned, a growing emphasis on flexibility when it comes to modern data center design. In terms
Yeah.
of what that looks like in practice from, I guess, both the design but also engineering perspective, just your thoughts as to the theory into the practice, if you like.
Yes, so I mean, we have to ultimately construct a data center, and we market the data center obviously at multiple different customers, multiple different hyperscale customers, and with their requirements changing rapidly, we need to be flexible and somewhat agnostic to be able to give them a solution, which meets their requirements. So, for example, we don't know at the time of site acquisition, whether the data center might be used for high performance compute with a hybrid cooling approach, or will it be more of a commercial cloud application which uses the traditional air cooling. So having a flexible but repeatable design framework, allows us to pivot to meet the different customer solutions.
Yeah, so that takes us on to global reference design. So how are
Yeah.
these GRDs helping operators balance the need to standardization as far as possible with the need to obviously adapt to local conditions, which, as you say, may change over time.
So we've implemented a global reference design, so that fundamentally when we it gives so fundamentally it gives us confidence in the data center that we will be building when we acquire the land. And the reference design, it's not a rigid one size fits all template. It's a an adaptable blueprint that provides a structured system to be able to standardize on certain items, but flex other items for either customer requirements or local adaptation or development constraints. But fundamentally, it gives us the edge in that we aren't starting from scratch. We are not reinventing the wheel. We remain, in control of our design, and that leads us on to being able to also control things such as our bulk procurement, our sustainability targets, the systems that we implement within the data center, the way the systems operate, and also it gives the edge to our operations team because they no longer have to, learn how to operate a brand new data center that they aren't familiar with. There's familiarity by standardization of the design.
And there's a lot of evolving regulations. For example,
Yeah.
EU's sustainability reporting standards. So just as because of that, how important do you think it is to embed compliance at the design stage?
Very important, and the reference design actually pre-validates compliance into the data center design, so we can enter that market knowing that our design is going to be compliant with all the different regulations, even though they might need to be tweaked for local regulatory nuances. But yeah, items like the EU Energy Efficiency Directive, we're able to understand that and position ourselves in the market in our reference design for compliance.
And I'm just sort of developing that point. It'd be good to
Yeah.
understand how GRDs can improve the way organizations measure and report when it comes to scope one, two, and even three emissions. Yeah, what do they contribute to that?
So, by having the reference design, we can also implement standardized equipment and not just standardized equipment in terms of makes and models, but also arrangements and system metering, for example. So we already can understand exactly how we're going to measure the scope emissions, directly from the data center, be it for electrical consumption, or from environmental consumption. So we can already pre-validate that, and we also implement, sorry, the 3D design. So we use BIM to pre-engineer the embedded carbon. That's within our data center design as well. So we can get a hold on that from on the front foot.
Okay, and AI, you referenced it at the top of the conversation. Clearly, it's
Yeah.
the sort of big sort of, I won't
Yeah.
say the elephant in the room because everyone knows about it and is talking about it, but AI, it's driving unprecedented demand for compute. So,
Yeah.
do GRDs, do they enable faster scaling to keep up with the growth that AI demands? Yeah, where do GRDs play in the AI space?
Absolutely. So it's important when you have a reference design, for it to be scalable. And like I said at the beginning, the customer requirements around machine learning and AI is changing rapidly. So by implementing scalable systems, it gives us the opportunity to grow and meet the demands of the customer, and not be completely locked in at mercy of the building. So we try and we implement, for instance, the electrical modules. We implement them completely external to the building, so that we can adapt them and we can scale them as and when required by the customer, very, very, very easily using prefabricated, pre-engineered modules. And on the cooling side for the AI applications, we've got an adaptable design where we can either implement a mixture of air or liquid cooling, as and when the customer requires it, and we provision ourselves for that in all our new builds now.
And just following up on the liquid side, is that direct to chip liquid cooling? Is submersion also on the agenda? Just what flavors of liquid, I suppose.
At the moment, we're focusing on direct to chip. That's mainly what our end users are. That's what our end users are currently asking for. But we're also, it's worth noting as well on the air side. I've also observed that our end users are also pushing air cooling further and further. So the demand is there. But yeah, as far as liquid's concerned, it's direct to chip at the moment.
Okay, and in terms of any challenges or misconceptions that you see when organizations try to adopt GRDs? Are there any things that constantly crop up, or does it vary? Just your thoughts, I suppose, as to obstacles there
Yeah.
might be when people look at adopting GRDs.
Yeah, no, really good question. So th there are a few challenges with GRDs. I think the first one is the first one, sorry, is the local adaptation. So it's quite important when you implement a GRD to leave room for that local adaptation and not try and be so rigid that it's just not going to work in a specific geography. Um, that will create resistance, um, and will impact the stakeholders involved in that project, and will be seen as a nuance and generally won't work. So it's important to basically, really understand what it is you want to standardize on. And then leave that room for local adaptation whilst meeting those global goals. The second one I would say is probably over standardization and becoming too rigid. Being able to control that flexibility, and particularly in our industry, control ever-changing requirements, and as a result, the need to deviate from a reference design. Having a true system to be able to, and the governance behind the deviations is really important, so that you can learn at a global level and also learn at a local level exactly what is and isn't working. Um, and then thirdly, I would also say innovation is quite a challenge because um, related, the customer, the end user requirements are changing so rapidly that you have a risk that your reference design can very quickly become out of date. So the framework of a reference design needs to embed and embrace the culture of continuous improvement, incorporating, emerging technologies, but also lessons learned from the project teams at a local level and customer feedback, reviewing what is working well, what isn't working well, and listening to the market is extremely important for successful reference design.
Okay, so if I understood you correctly there, you don't sort of come up with a set, file them away, and then 2 years later have a look at them and do
No.
it's a continuous. I mean, are we talking,
Yeah.
without exaggerating, are we talking sort of monthly, or is there an optimum sort of time to look at upgrading more? Or is it very much a continuous process where you've got a document and people are welcome to sort of contribute to it as yeah, things change?
Absolutely, it's a continuous process. If you put periodic review cycles on some of the documentation, I mean, to be honest, it works for certain areas of the reference design, but other areas it needs to remain continuous, because you can imagine, all the different hyperscale end users, they are learning at the same pace as we are. So, and at the same time, for example, the delivery teams are also learning, what's easy, what's good to deliver, what's a challenge to deliver. So there's lots of lessons learned, there's lots of change. And someone told me, a couple of years ago that the only constant is change. So it's a very much a living framework. Um, that's always evolving.
Okay, and maybe just in finishing, looking ahead, do you think that GRDs are going to become industry standard for future-proofing data centers? And if that is the case, is there anything that still needs to happen to make that or a reality? Or yeah, just your thoughts, I suppose, as to how GRDs will develop into the future, how important they'll become.
I think that well, first of all, they are becoming more common, from what I'm hearing in the market, and I think that's a good thing. And I think that actually adopting an openness, within the industry as to and implementing standardization across the industry, is a good thing. Ultimately, we're all delivering compute applications, right, in different geographies. So I think it's important that we, as an industry, don't reinvent the wheel. It's important that we all understand what is required. We all understand. what the targets out there set by regulators and by the end users are actually mean. And having openness and transparency in the industry, in my opinion, is only a good thing.
Yeah, it did occur to me. I think the Open Compute project comes up with reference designs for what they do. Do you think something
Exactly.
similar to that could come across the industry more widely?
Yeah, I mean, Colt DCS are also involved with the Open Compute project, but I think yeah, that's a great example of how collaboration can solve industry problems with an openness and a trust within it.
Excellent. I mean, it's been great to chat, Matt, and thank you so much for sharing so many great insights into what's going on
No,
in
you're very
terms of the
welcome.
global reference designs. Really enjoyed it, and thanks for your time. Thank you.
No, you're very welcome.